right, this video will show you how to solve polynomial functions. And solving polynomial functions means several things. I could ask you to find the zeros of a function, I could ask you to find the roots of a function, or I could ask you to find the solutions of a function. All of these things mean the same thing. So I'm looking at where a graph would cross the x-axis, okay? These are going to be called any of those three words: zeros, roots, or solutions. So if your test asks you for any of those three, that means your answer will look like x equals n numbers, okay? So to find these solutions, roots and zeros, we are going to set the equation equal to 0 and solve for those x values, okay? So when we are solving polynomial functions, you are going to factor things out. So looking at this first example, and I look at x cubed, 3x squared, and negative 28x, the first thing I see that they have in common is an x. So I'm going to factor out an x for all of them. When I take out an x out of x cubed, I get x squared. When I take out an x out of 3x squared, I get 3x. And when I take out an x out of negative 28x, I just get a negative 28. Okay? From here, you are going to factor this a little bit further, this trinomial, okay? And a quick review on factoring here, you're asking what two numbers multiply to give you negative 28x squared, and also those same two numbers need to add up to my middle term of 3x. Okay, so you think about it, and hopefully you're coming up with the numbers 7 and 4. But we do notice that the product has to be a negative product. So that means one of these two numbers has to be negative. And then I look and see that my sum needs to be a positive number, meaning that the smaller number is going to be my negative one. So these two numbers, 7 and negative 4, those are the numbers that become your factors, okay? So I can actually just jump in and go x plus 7 and x minus 4. And then don't forget about the x that you already factored. So what's happening here, we said that we need to set the equation equal to 0. So I'm going to take this factor and I'm going to set it equal to 0. I'm going to take this factor and set it equal to 0, and this factor, and I'm going to set it equal to 0. Okay? So then you solve for x. This one's already solved, so I'm done there. This one, I'm going to subtract 7 from both sides. So I end up with x equals negative 7. And this one, I'm going to add 4 to both sides. So I end up with x equals 4. Okay? And your final answer is just going to be those numbers listed. The order that you list them does not matter. Okay? So how can I check that I did this correctly? My polynomial, the highest degree is 3. Therefore, I should have 3 answers at the end here. Okay, that's how you can check if you did that correctly. All right, so now we have number 2 here. Same thing, try to factor something that they all have in common. So first thing that I see that they all have is some x's, right? So 2 x's can come out here. And anytime that your first term has a negative, just factor that out. So now that we factored out the negative x squared, I am going to go in and see what's left. So here I have an x squared left. Because I factored out a negative, this is going to also become a negative. If you were to multiply it back in, negative times negative is how I get that positive. I still have a 4 in there, and then only 1x because I took 2 out. Then this is going to become a plus, and 4 is left inside, okay? So now we have this trinomial, and we're going to factor it a little bit further. So think about what two numbers multiply to give you 4x squared, and also add up to give you negative 2x, okay? So hopefully you're thinking 2x and 2x. And I'm sorry here, this is supposed to be what two numbers add up to your middle term, and that's a negative 4x, okay? So that's how I get the 2x and 2x, and these are both going to be negative because I need that to become a negative sum. So remember, that means that those two are your factors. So I have x minus 2 and x minus 2 again, and bring down that negative x squared, okay? So negative x squared, technically x squared is x times x, okay? And one of them is negative because that product is negative. So if I were to set this equal to 0, I get x equals 0. And I set this one equal to 0, so that's x equals 0. And you're going to do the same thing with these factors, set them equal to 0. And you end up with x equals 2 and x equals 2. Which is good because I want 4 solutions based on my exponent there. But when you list your final answer, it is not necessary to list them twice. So 0, 0, 2, 2. It's going to be the same 0 for both times. So just have to list them once there, but you are aware that they repeat. So there are 4 solutions. That's how you're checking your answer. Okay. All right, number 3. So for number 3, it's a trinomial here, but the first power is x to the 4th. So we have to be careful when we factor that our factors are, instead of just having x, are going to have x squared. Okay. So you're asking yourself still, what two numbers multiply to 36 and also add up to a negative 13? And hopefully you are coming up with 4 and 9. And again, they have to add up to a negative sum, so I'm going to add negatives there. Okay, so this is x minus 4, and this is x minus 9. Now you have two options here. If you remember difference of squares, you can jump into difference of squares from here. If not, I'm going to show you another method at the end, but I'm going to start off with difference of squares. So for difference of squares, anytime you have two perfect squares within the factor, that means you can go into x plus 2, x minus 2. Hopefully you remember this from Algebra 2. Same thing here, I have two perfect squares, so this becomes x plus 3, x minus 3. Okay? Then you're going to set each factor equal to 0. X minus 2 equals 0, x plus 3 equals 0, x minus 3 equals 0. This step where you're setting them equal to 0 is not always necessary if you understand how to solve for the x there. But essentially, this is going to become x equals negative 2, x equals positive 2, and negative 3, and positive 3. So my final answer is just me listing those numbers. And again, I know I'm supposed to have 4 solutions because of that highest exponent in the function, okay? If you didn't remember a difference of squares, you can go from here. I'm going to show you that second method and just set those factors equal to 0. So what ends up happening is I set this equal to 0. Then I add 4 to both sides, and I get x squared equals 4. When I take the square root, x equals plus or minus 2. Okay, so there's my plus and minus 2 in the solution. And you can do the same thing to x squared minus 9, set it equal to 0. So x squared equals 9, take the square root, x equals plus or minus 3. And there are my answers. So whichever way makes the most sense to you. There's different ways to do things in math, so I am totally okay with you doing either. Okay? All right. So now we have a cubic function. So I should have 3 solutions based on that. And I am going to have to factor here by grouping. So when it's not a trinomial, I have to see what other methods they are, okay? So either greatest common factor, you're factoring a trinomial by asking what two numbers multiply to that c value and add up to the middle term. But when you have 4 terms like this, you are going to want to factor by grouping. So take this first part here and look for what they both have in common. So I have x squared. When I take out an x squared, I end up with x plus 3. Then I look over here. I take out a -1. That's all I can take out. When I do that, I get x plus 3 on the inside. Okay? When you factor things out, you are hoping that these terms match. That is a good sign. That alone is going to be one of your factors, x plus 3. And your other factor is going to be whatever you took out. So x squared minus 1. This x squared minus 1 is another difference of squares. So I'm going to jump into x plus 1, x minus 1. And again, if you want to go from there and set it equal to 0, that will work too. Okay, so when I set my factors equal to 0 here, this is going to become x equals -1 and +1 and -3. So then I can just list my answers, my solutions, my roots, all mean the same thing, okay? And just to go back to what this actually means mathematically, if I were to graph this cubic, it would be going through -3 and -1 and +1. Somehow it's like crossing at those points, okay? That's what it means graphically. That's not what the graph looks like, but just so you get the idea. Okay. Moving on here, I want you to go ahead and try to pause the video here and attempt these two questions. See what you can do. Try to think about which method would be best to use in this case. Okay, so hopefully you had some time to go in and think about what you wanted to do. So here, you have two options for this first one. You can either do difference of squares, or you can try to factor out what they have in common, which is an x squared first. I'm just going to go that route. I can show both in a little bit. So if I take out an x squared, this becomes x squared minus 4, which then becomes a difference of squares, x plus 2, x minus 2, and then this is just x squared here. Remember that this tells me how many solutions I should have, so I should have 4 solutions. This means x times x. So really, I have x equals 0 twice. Then I set these factors equal to 0, and I get x equals -2, x equals +2. Okay, so I'm listing my factors, 0, -2, and 2. You could have also looked at the original problem and seen a difference of squares from the beginning, which would actually factor to x squared minus 2x, x squared plus 2x, and then go from there, okay? And then you factor out a common x from here and factor out a common x from here. Set your factors equal to 0. So this one becomes x equals 0, this one becomes x equals 2, x equals 0, x equals -2, and I end up at the same place. So whichever way makes the most sense to you, go ahead and do that. Okay. And this one, we have 4 terms, so I'm going to go ahead and factor by grouping. So I'm going to group these first 2 and these last 2. For the first group, I have x squared in common. That means I have x plus 2 left inside. For this second group, I have a -4 in common, which means I have x plus 2 on the inside. So good sign if these match, okay? That's going to be one of my factors, x plus 2, the one I have in common. Then my other factor is going to be whatever I took out. So x squared minus 4. Okay, this one on the right is fully factored already, but this one can break down a little bit more. That's a difference of squares again, so they are going to be common. Make sure you are familiar with them. Okay. When I set these factors equal to 0, I get x equals -2 and x equals +2. And this one is x equals -2 again. So that's good. I should have 3 solutions, but I only have to list that -2 once. Okay, and so luckily in these notes, all of our functions went through the x-axis, but there will be times that some of your solutions may be imaginary, kind of like we had with the quadratics. Okay, so when the parabola was opening up, we didn't have any actual zeros visually on our x-axis, so they would be imaginary solutions. All right, the second part of 2.3 is just looking at polynomial functions and their graphs. So we just solved for the zeros where they're going to cross the x-axis. We can also call those the solutions or the roots. Now we're going to look at their graphs and their end behavior based on these exponents, okay? So hopefully you all know the equation of a line, and the parent function of a line starts at 0, 0, and it has a positive slope. You can extend that in both directions. Just kind of looks like this, okay? Technically, if I were to label the exponent here, this is just x to the first power, okay? It is an odd number, 1 is odd, and so if there were to be an exponent, it would be 1. The other way this one could be graphed is if it has a negative slope, it would be going down the opposite direction. So going down this way. Okay, so linear function, it's just a straight line. Hopefully you know that. Hopefully you remember that. Just a regular, normal sketch of these graphs is perfect. So you don't need to graph them perfectly or anything, okay? Second type of graph you are familiar with is a quadratic. We just spent time graphing quadratics last time I saw you. So this is just general U-shaped graph here. Okay, like I said, you just need to know how to sketch it. And x squared, so the squared is an even exponent. So just remember that. We're going to talk about even and odd functions here in a little bit. If it has a negative in the front, it means it's opening down. So my graph would look like this. Okay, so quadratic is my U-shaped graph. Then we have x cubed. And x cubed, the parent function, kind of looks like this. It's kind of like a snake. It goes up this way. Okay, so think of it as a snake-looking graph. And if I have a negative in front of it, it just means it's going to open, or it's going to snake down the opposite direction. Okay? So that's the difference between a positive cubic, which is another odd function, odd number in the exponent, versus a negative cubic function. And then x to the fourth is another even one, and this one is just going to be a wider U shape. And if you want to make a table of values, you'll see the difference there, but essentially it's just going to open up a little bit wider than your regular x squared. And same thing, the negative, all it does is it makes it reflect across the x-axis. So that's a quartic, x to the fourth power. And the last one is a quintic. So this is x to the fifth power. And this is just going to be a skinnier snake. Skinnier snake. Okay, so it goes like that. It looks very similar. Now, obviously, when we apply things, transformations, these are going to change, okay? These can get crazy. These can go, technically, it can go up to 5 times across the x-axis, like 1, 2, 3, 4, 5. But that happens later. For now, this is just the parent function. So now that we looked at the general graphs up to exponents of 5, let's talk about end behavior and what this means, okay? So end behavior is a term that helps us describe what's happening to the graphs as we approach x from both sides. So I'm just going to write that down really quick. So think about what the ends of the graph are doing as you approach x from both sides. Okay, so when you look at the graph, what is happening to your y value as you look at the x value? Okay, so if I have an odd degree, so odd numbers, 1, 3, 5, 7, 9, and so on, okay, here is what is happening. So you have two options. I can either have a positive graph, so A is going to be positive. Remember, A is just the sign. There could be a number, but the sign, if A is positive in the front, then you're going to follow these. If there's a negative, it's being reflected, so it's going to change the end behavior a little bit. So if A is positive, as x approaches negative infinity, f of x will approach negative infinity. And as x approaches positive infinity, f of x will also approach positive infinity. So hopefully you remember that f of x is the same thing as your y value. So if I were to think about my most basic positive function, an odd positive function, remember I said the equation of a line technically has a 1 exponent, so I know it's odd. And this is a positive slope in the equation of a line, okay? So here is what this definition means. As I look, this is the left side of my graph. The negative infinity would be the left. If I go left on my graph, what's happening to your y values? They're also going down. So that's why it approaches negative infinity. As I look at the right side of my graph, that's what the positive infinity is. What am I doing? It's going up and to the right. So this is why it's going up. So this is showing you if it's going up or down, essentially, as you go left and right. Okay. Now, same deal with the odd degree, but what if A is negative? Okay, so you're always going to start off your end behaviors the same way. You're going to say as x approaches negative infinity, f of x does what? And as x approaches positive infinity, f of x does what? So really the only thing that's changing every time for your end behavior is what y is doing, what f of x is doing, okay? So I'm going to draw the picture here before we fill that in. So we're talking about an odd degree, remember that, so 1, 3, 5, 7, 9, and so on. So if I have an odd degree and A is negative, so my slope is negative, I'm going to go back and think of my most basic odd function, so linear, with a negative slope. As I go to the left, okay, my y's are actually getting bigger this time, positive infinity. And as I go to the right of my graph and I follow along those right values, my f of x is actually going down to negative infinity. Something to remember here is that you always want to look at the highest degree of whatever function you are looking at. So they won't always be in the correct order from highest exponent down to the least smallest exponent. So you have to look at the entire function before you determine if it's going to be odd or even, okay? And we'll do some examples there. Next, we have an even degree. And so, again, we're going to talk about what happens when A is positive first. And all your end behaviors are going to start the same way. So as x goes to negative infinity, f of x does what? As x approaches positive infinity, f of x does what? Okay, so again, this is the only thing really changing in your answers, and you just have to think about those graphs. So even degree, I'm thinking of the smallest just because the most familiar function I know that is even and positive. When I think of an even function, I think of a parabola. Okay, so that's the basic picture of a parabola with a positive a value, so it's opening up. So ask yourself again, as you go to the left side of these values, what is happening to your y values? They are going up. They are approaching positive infinity. And as you go to the right side of your graph, your y values are also going up. Okay, so this one has positive infinity for both. When a is negative for an even degree polynomial, again, you start off the same way. As x goes to negative infinity, f of x goes to what? As x goes to positive infinity, f of x goes to what? So this is what's changing. And now I'm going to draw the most basic even function I know, but with a negative in the front. So what that's doing is it's reflecting it across the x-axis. So what is happening on this graph as I go to the left, my y values are going down to negative infinity. And as I look to the right, it's going right and down. So negative infinity there as well. Okay. So we are going to do 3 examples here. I highly suggest you go off to the side and sketch the most basic odd degree function that you know and the most basic even degree function that you know. I always go back to linears and quadratics because we do those over and over. So hopefully you know what the graph of those looks like, okay? So the question is going to say this. It's going to say state the end behavior. So first thing you want to do is look at the entire function here. Okay, there are 4 terms, and look at your highest degree always. So highest degree. So first identify, is the highest degree even or odd? So you're thinking of an odd function. And if there is a positive or negative in front of that term. So in this case, it's just going to be positive. So what is your most basic odd function? We know it's linear with a positive slope, so it's going that way. I know that this is a cubic, and it's really going to look more like a snake. But again, what if I gave you x to the 11th? You don't want to try to figure out what that looks like. Always go back to your most basic odd function. Okay? Always start off your statements the same. As x approaches negative infinity, f of x approaches. As x goes to positive infinity, f of x approaches. And then look at the sketch of your graph. That is the easiest way to do it, I think. So as I go to the left, my y values are going down. So that means negative infinity. As my x values go to the right, my y values are going up. So that is positive infinity. And you're done. That is the end behavior. Okay. Okay, so go ahead and pause the video here and attempt to do number 2, and then we'll go over it. All right, hopefully you gave it a chance here. Looking at this function, you want to look at the whole thing, because if you only look at the first term here, you're going to say that it's squared. That's not the case. That's not the highest exponent, okay? You want to look here, and it's x to the 4th. That's the highest exponent. So then, once you identify the highest exponent is an even. And that 4 is positive, so I'm looking at an even positive function. Okay, so the most basic even function I know is a parabola, and because it's positive, I'm thinking it's opening up. Okay, and then I'm going to go ahead and just start my end behavior statement. As x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. So, as your x values go left, what's your y doing? It's going up to positive infinity. As your x values are going to the right, your y values are still going up to positive infinity. Okay. All right, this last one is kind of tricky because it can get a little bit confusing. So let me go back and show you the difference between the last two and then this last one, okay? So in my number 2, there is a plus sign separating my terms. Okay, so I have x squared and then plus 4x to the fourth. And then for number 1, again, I have term separated by plus, term separated by minus, term separated there. What's going on over here is I have 3 different terms. So I have this, this, and this. But they're not separated by a plus or a minus. So really what's happening is that they're being multiplied. And when you multiply exponents, they get bigger and bigger and bigger, okay? So what's really happening, we're multiplying the exponents. Here I have an x cubed that's being multiplied by, if I went ahead and double distribute it, that would become an x squared term, and this would become an x to the fourth term. So what happens when you multiply exponents? You end up adding them. So this function actually is an x to the 9th function. And then another thing I need to be careful about is that a value, okay? So these are all being multiplied, but then just looking at your x values, only this first one has a negative attached to it, okay? So that negative is going to follow. Oh, that doesn't look attached. So this is going to actually be a negative x to the 9th because of that negative 4 that's attached to the x cubed. All right, so now that you did that, which is tricky, so always pay attention. Are the terms separated, or does it mean that you have to multiply it through to create a bigger exponent? Okay, so now I have an odd, because 9 is odd, the exponent, an odd function, but now it's negative. Okay, so remember, I always go back to my most basic odd function, which is a linear function, but negative means it has a negative slope. It's going down that way. Okay, so start off your statement. As x goes to negative infinity, f of x goes to, as x goes to positive infinity, f of x goes to. So follow your graph. As you go left, your y values are going up. And as you go right, your y values are going down. And that is your final answer. So this is the end of the notes for 2.3, both solving those polynomial functions and just knowing what the general graph will look like.